studied about a lot about scheduling, right? So since starting from the queuing theory aspects, we have looked at, how bufferless queues will look like. So basically we were looking at the switch architecture only. Okay, so we were looking at that, what if we have buffers, if we do not have buffers, what are the different types of switch architectures, and then how do we theoretically analyze the performance of such systems. Okay, that's what we have seen. And then we did not propose, we saw few proposed, already proposed algorithms. Yes, I think somebody's mic needs to be muted. Just take a look. Yeah. So, yeah. So what we were looking at is that, there are several scheduling techniques that we saw, some proposed scheduling techniques for more improvement in the switch capacity. So for that matter, we looked at VOQ, and then we looked at, the various improvements on that, where we looked at parallel iterated matching and round robin matching algorithms. Okay, so we ended the class yesterday with round robin matching, and there was one slide left which was talking about that. I'm not going through that slide anymore because I will talk verbally about it, because that slide was basically talking about that, how good or bad the round robin matching will perform. Okay, so this, I would like to put up this question to you guys, because you already know what randomness can, what kind of performance randomness can give, what kind of performance a particular schedule will give. But if that schedule is round robin, then how will it perform, what will be the issues, and how the system will suffer when round robin is used, and how the system will benefit if we are using round robin matching. So one of the easiest benefits is, yes, that you are not using the the random selection method which was used in PIM, but which reduces a lot of contention. But again, when you are having round robin, so you are basically dependent upon a schedule, right? So that, how will it cause the problem, that you have to think. Okay, so I would like you all to think as to how this round robin matching will actually cause problem. Okay, so I will upload the slides accordingly, but today we have only 4 classes left before mid-semester examination. Okay, so and this IP address classification and filtering, that module is still left, so I will start that module today. And yeah, so that is why there was a request for changing the quiz schedule, and I could not change it because of that, because only 4 classes are left. And also I had asked you that, or I had basically told you that, I will take some class extra for solving quiz numericals. But I don't see anything in your calendar that any tutorial class is left or anything is left where I can actually take a schedule for quiz. So let us take the quiz first. Then after that, if you give me some time, because last week now I know that all of you will have a lot of tests and quiz from other courses. So I did not say anything about that, and we missed one course, one class in between. We missed one class in between because of all the issues that happened, that the academic section told that Friday class is there or not there, something like that happened, some confusion. So one class was missed with that. So you guys give the quiz. Let me see how you perform with the queuing theory part. If you are interested still, then I can take the class. Let me see. I can take an extra class in that case. Even after it is midsem, that is also fine with me. Or let me see the calendar. You have a midsem break also. And otherwise, before midsem, if you want, then you can suggest me any time where you will be free, and I will ask. I will try to be available at those times, and I'll try to match up those times, and I will. So midsem starts 28th is our midsem. Okay, break is 1 week after that. Okay. All right. So if you want in this week, in the next week, so let me know if you want some time for queuing theory numericals. Then just let me know. I will try to provide you some help with the numericals. Okay, some practice. Yes.
Could you provide some practice problems so that we could try it on our own, and if we have doubts, maybe we could ask you rather than
In
using
that
my
case,
time.
okay, you don't want the solutions in that case, I can send you the practice problems. That is fine with me.
And if we have doubts, then we can ask you.
Uh, okay. Can I give you after the quiz? Is that okay, Shai? If I give you after the quiz, because let me see how the quiz goes, or you guys are completely not okay with that, or you still want some more practice problems to do.
In that case, don't give the solutions then, ma'am. At least some questions so
Some
that
questions, some questions. Okay, so what I will do is tomorrow's Friday, no? Okay, fine. So I will give you by Saturday morning. Will that do? Because tomorrow I have a few lectures outside. So I'll try by tonight or maybe Saturday morning in that case. I will try to do that. Okay.
quizzes on Monday, right now. 6
Monday evening quiz is there. So you will get Saturday and Sunday 2 days to solve. And Monday is also there full day. Okay.
Thank you.
Yeah. All right. So I will do that. Okay. So I will just give you the problem sets and you can solve it by yourself. Okay. All right. Let me start today's class. So today we are going to look at IP packet lookup and classification module. Okay. So basically this module is called as IP packet filtering and classification, but we are going to look at packet lookup first, and we are going to look at those other aspects of it. So this part or this module has been taken from this book, that is Network Routing Algorithms, Protocols and Architectures by Medhi and Ramasamy. Okay. If you want the I will share the material also, the chapters that are there in the book. Maybe I can share the materials also with you. One paper is there, research paper, from where parts of it has been taken. So maybe I'll share the research paper also with you. All right. So let me get into the portion. So here, routing and addressing is what we are going to look at, and I'm sure all of you are well aware of these two from your basic networks course. That is, when we are talking about routing, we are referring to the ability of a network to send some information from a point to another point. Okay, now how do we find that? So we do that by finding a path between these 2 points, and we need to find the path very efficiently and very quickly, and that's where the routing algorithm comes into picture. Okay, whereas addressing is the way in which you identify a particular source or destination or a particular node that is a part of the network. Okay, so these play a very important role in your network, both addressing and routing. So we have referred to this kind of addressing as IP addressing, right? So we use IP addresses where we have two parts. One is the network ID part, another is the host ID part. So network ID will identify your network address and host ID will identify the host in it. Okay. So now if we are looking at routing per se, we know that routers are basically cross points in the internet or in the backbone, internet backbone, which basically help us to send the packets to their correct path towards their destination, okay, or to the best path towards their destination basically. So what should be the functions of router? It should, first of all, it should read the destination address correctly. Then it should identify the outgoing link to which the packet needs to be forwarded. After that, it needs to forward the packet and then ensure that the forwarded packet was delivered reliably to the particular destination. Okay. So these are essentials or essential functions of a router. I'm skipping through these parts fast because these are your previous course materials, but just I'm going through it a little bit. I will start explaining in details when we get into the uh, core part of this module. So what do we need for efficient delivery of packets? Okay. So first is that routers with reasonable amount of buffer space should be required. Otherwise, if buffer space is not there, you will have loss of packets. Then you should have adequate bandwidth in your link. The link bandwidth should be adequate so that you can transfer the packets fast. Then while transmission, minimum error should be there. That is also needed. And then fourth is that router's efficiency in switching a packet to the appropriate outgoing link. Okay, that is also very, very important. Okay, so you first find out that what is the address to which you need to send your, or what is the address or destination address of that packet. And this is the first thing that the router efficiently needs to find out. Okay, then what needs to be there? So after this, you need to ensure all of these requirements for the delivery of packets. All right, so then, okay, so let's get to the IP addressing part. Okay, because we are actually looking at this issue, that is IP packet filtering and classification. So first we will look at the uh, issues that we have with different IP addressing methodologies. So first is that you all know what is IP addresses, and they are unique identifiers of hosts. And routers do have information of some hosts with them. So whenever a packet arrives to a router, they basically check their header for the destination address. They read that address and then find out that if in their routing table, and then they just try to find out from the forwarding table that whether there is an entry made there or not. If an entry is there, then they send it to the correspond, or they find that what is the corresponding outgoing port, and then the packet is sent to the corresponding outgoing port. That's how it works, right? So IP addresses do have the network ID and the host ID, separate parts. Network ID will represent the network part, and it will basically ensure that this each network ID will have a chunk of hosts associated to it. Okay, so even if your router has some information about the network ID, particular network ID, and you might think that okay, if this is the network ID and I can actually give my host, just find out that okay, what is the corresponding outgoing port for a particular network ID, and then you will forward your packet towards that. It may not always work because it has a large number, it can have a large number of hosts associated to it, and not necessarily that all the hosts will be there together. Okay, through that same link, not necessarily that through that same outgoing link you can send your packet to the hosts which correspond to that particular network ID. Okay, so this is a question that I have put here, that is IP addressing is not geographic in nature, and why is this so this is, I think you all might remember this question from your um, computer networks quiz or final exam. I think I have given this question somewhere at least. Okay, because this is a very important question when it comes to networks. Anybody can ask you when you are going for an interview or anything. Anybody can ask you that. It would be very easy to just find the geographic location of a particular device and then give that address as an IP address. Okay, so can we get an answer for this? Because this question is already, I'm sure most of you who are third year batches and even fourth year batches, most of you are aware of this answer. So can I get an answer for this question? That is, why is IP addressing not geographic in nature? Give me some answer. What do you think?
Ma'am, is it like IP address has to follow the basically the topology rather than the network topology only it has to really calculate?
There's a lot of background. We're talking about network topology. It has to look at the network topology. Is that so? Because I could not understand. A lot of background noise is there.
Yeah, it's some festival is going on, ma'am. So a lot of noise pollution is there.
Okay, okay. So it was okay for now, but what did you say? Can you repeat once more?
Basically, IP address has to it's dependent on the top. It has to depend on the topology of the network. It is not linked with the geography.
Yeah, that depends on the topology of the network. But I can still say that, if I have a packet and every time I have I am sending a particular, I mean, when you say the topology of a network, you can also say that it is basically made up by the nodes which are associated to that. No, let us think about a wired scenario. So when we are talking about the network topology, we are basically talking about the nodes which are connecting that entire network, right? So if you give the address of these nodes, assuming that these are static entities, if you give the address of these nodes according to their location, then what is the problem that is going to get to you? I mean, what is the problem that you are going to get? So this was Jayanti, I believe. So I would like to hear from the third year students also, because this is what this question is common to all of you. And if not, at least I have asked this question to you in the class also. That I clearly remember. So what is the answer for this question?
Ma'am, we can move from one network to another. So, um, in that case, our IP address could change.
So in that case, so if you move from one network to another, geographic address will not be helpful. Are you saying that?
Yes.
Why? Why? Can you just explain once more? Can you explain? Hello?
Yeah. So, sorry, ma'am, my net went.
Yeah, yeah. Can you explain why you think that it will not be good if you are moving from one ISP to another ISP and you're using location as an address?
One thing is the number of devices in a geography might also be different. So then we might have to use the fixed number of, say, bits to represent. Uh, if we are restricting ourselves to a particular geography, then we have to also guess that how many bits we have to allocate for the number of devices that can connect to a network. But that might vary depending on if we are an institution or a home network. So it's not a good idea to do it geographically.
Okay, close enough, yes. And any other reason? This is a correct reason. One more reason. There are many reasons why it is not geographic. So any other reason?
Hello, ma'am. Am I audible?
Yes, yes, you are audible.
There are virtual private networks, right? So one can remotely log in from another place to a private network. So this also tells that IP addressing is not geographic.
Yes, that is also one reason. Any other reason? Any other factor?
IP address are allocated arbitrarily. So, similar address can be found like one part of suppose America and one part of India. So they don't have any relation, geographic relation.
That is, you are keeping IP addressing is not geographic as a premise. Okay, I think what you want to say is that the scope of IP addresses, the fixed IP address that we have um, currently, that is small. So we are repeating the addresses in different geographical regions. So that is why if it is geographic, then it wouldn't help us. But the question is in another way, that if I actually use America's location and I use India's location for India's devices, then what is the problem? Okay, so one thing I think people are missing out, you can move right from one place to another. Every time you move, every time you go to any other place, every time you are joining through some other network, if you are still in your house, or you can join via your mobile phone or to some, I mean, you can join via your mobile phone and use Wi-Fi, or you can use a Wi-Fi router, or you can use your LAN and all that. So every time for so many devices, we have to give a geographic address for the same house. Okay, so many devices will be attached to the same geographic address. In that case, so identifying will also become difficult, no, in that case. And if you move around, that will also be difficult to basically keep a profile of every device, that this device was at this moment in this location, then next moment it was in that location. So that is also a very difficult task to do. So that is why if you simply in general, what we do, we randomly allocate IP addresses when it comes to hosts like us, okay, who are like mobile and who are users which are not continuously using internet, or uh, huge bandwidths who are not using. Okay, basically the hosts which are dynamic IP addresses most of the times. So for those reasons, geographic addressing is not considered to be a good idea. Okay, and of course, this one reason that was given for the ISPs, that is also a valid reason, and for the VPN part also, that is also a valid reason. All right, so these are the some of the reasons why geographic addressing is not considered. Now, what are the phases that are required for addressing? First is that you look up the address and then you update the corresponding routing table. Okay, so now this will take time, no, to look up the address and then update the routing table. So what can we do? So the first thing is that you would want to minimize the switching time at routers. Okay, so how can we do that? So some effective mechanisms are required which can do three things. One is that you look up an address efficiently so that you take lesser time. Once you do the lookup, then you identify the appropriate outgoing link, and then you quickly process the packet to the forward or forward the packet to the corresponding outgoing link. Okay, so forwarding and all, we know it will be dependent upon what are the things we have already studied. We have already studied about the switch capacity. We have already studied about what kind of buffers or what kind of scheduling mechanisms will ensure more efficiency or less efficiency, etc. So that goes with the processing of the packet. Now, what are the two things left? That what is the lookup, I mean, how to efficiently look up the address and how to identify the appropriate outgoing link. Okay, now identifying the appropriate outgoing link, that you have to find out depending upon what is the routing algorithm. Okay, depending upon what the routing algorithm gives out as a result, you will be able to find out that, okay, what would be the appropriate outgoing link for that particular path. What you are left with? You are left with this, that how to look up efficiently, look up an address efficiently. So this is what I was talking about, that when you are looking for updating the routing table and for finding out the appropriate output port, you are basically dependent upon the routing protocol mechanism. Okay, now Acha, this part, no, classful addressing and classless addressing, I have kept it for one reason. I'm sure all of you know this, and all of you are like, I need not revise this part about classful and classless addressing. This is basic networks course material. But why I have kept it is because I want you to know that how difficult or how easy it becomes when you are using classful addressing scheme or classless addressing scheme when you are looking at lookup algorithms. Okay, so let me just give you one idea. So this is the dotted decimal notation. We have, let me just go to this one. Sorry, where did it go? Just a second, I just added it. Why it is not showing? Now it is showing. Okay, so okay, so this is the case with classful addressing, right? So we divide the set of IP addresses into different classes depending upon, you know, what is the range of address or depending upon the range of address, right? So like 0 to 127, the first byte, first bit, if it is 0, then we put it into class A addresses. So that means all the IP addresses starting with 0 to 127, they will fall under class A. Class B will consist of all the IP addresses falling under this range, that is 128 to 191. Class C will be 192 to 223, and class D will be 224 to 239, and class E will be 240 to 255. Okay, as per the dotted decimal notation, this is how it will look like. So anything that falls under these, any address, if you look at, if it falls under any of these, then they will fall under these classes: class A address, class B address, or class C address, etc. Now if you can easily identify that which class does it fall under, and then you can easily then just send the packet or forward the packet to the corresponding outgoing port. Okay, so you can have like, okay, for this particular set, these are the outgoing ports that we have, and we can send the packet via this particular outgoing port if it belongs to this particular class. And then these are the uh, features, or these are the basic tasks that need to be done on this particular packet, and it needs to be sent via the particular outgoing port. Okay, so this is how classful addressing looks like. Okay, so a host can use a multicast address as the destination address for a packet generated to indicate that the packet is meant for any host on the internet. Okay, so this is for multicast address, so that you already know that with the help of multicasting, you can send a packet to many other hosts belonging to the network. Okay, so let me get to what are the problems that we will get if you are having classful IP address. Okay, so first thing is that you have too few network addresses for large networks. So in classful, you will see that class A and class B are the large networks. Okay, they can accommodate a large number of hosts. All right, but that may not be sufficient, right? Of course, anyways, 32-bit addresses are not sufficient for us now. So that kind of classification will also not be sufficient for us in that case. Okay, so that is one problem. What is the second problem? That is this two-layer hierarchy is not appropriate for large networks with class A and class B addresses. So what we do, we simply go with subnetting, which is there in classless addressing. Right? You all know what is subnetting. I will not go to this part. So we know that, with this subnetting, we can have a subnet part and a host part, and we can easily identify them separately with the help of the last X bits that we put. So next is it is inflexible. Okay, so suppose a company, this is an example that is given. So suppose a company requires some 2000 addresses. So if you put it under class A and class B, then many other addresses are there which will be simply just wasted. Okay, because it gives too much because it has too much of space for other hosts. Whereas if you use class C addresses, then it will become insufficient for this. Okay, and moving between these two and still belonging to the same company, that will also become difficult if it happens for classful addresses. Okay, so in these cases, what we can do, we can use classless interdomain routing or CIDR. We already have enough knowledge about it from our computer networks courses. Now, what is the next problem? That exploding routing tables. Okay, that means your routing on the backbone internet, it needs to have an entry for each network address. Okay, so I told you right now that if you have classful addressing, you know that okay, my address will belong to this particular set if it starts with this particular number or this particular bit. Okay, but the problem is that your routing table also has to have that much of information to know that if it belongs to this address of this class, then it will go to that particular outgoing port. Okay, so the size of the routing table will keep increasing in that case. All right, so that is the reason we go for this classless interdomain routing, and we try to reduce the size of our routing tables and also reduce the time for updates. Next is, of course, we already know that IPv4 is not sufficient for us, so we need to go for IPv6. Okay, so we are going to look at the issues. Subnetting or netmask, I'm not going through it because you all are aware of this. I will go through CIDR also, you all know. I will go through the IP address lookup algorithms. Okay, so let us look at this. Whenever we are going to make a forwarding decision for a packet, what are the two decisions or what are the components of this decision? Okay, first is you want to find the address of the next hop router to forward the packet, to which you will forward the packet basically. Okay, so first you need to find the next hop router's address. Then what is that next thing, that in order to reach that next hop router, what is the outgoing interface that you need to use? Okay, so these are the two decisions that need to be made when a packet reaches or arrives a particular router. Now, what are the key factors that would affect a routing system? We have already seen it. So first is the link speed. Then what is the router data throughput? Okay. Then what is the forwarding rate, packet forwarding rate? And then number 4 is that quick adaptation to routing changes. This is very important, this quick adaptation to routing changes. Okay, your topology can change. There can be link breakage. There can be some other congestion going on. Okay, so many things can happen. So in the routing system, it needs to adapt quickly to such changes in the core. Okay, so these are the key factors that affect a routing system. Now, when we are looking at lookup, IP address lookup, what is the impact of addressing on lookup? Okay, so first is that the forwarding of packets, as I told you, that it is very straightforward when it comes to classful addressing. You simply need to classify what class it belongs to, and then from your routing table, assuming that your routing table does consist of a lot of information. So then from your routing table, you can find out what is the corresponding outgoing interface. Okay, so it becomes a lot easier when it comes to classful addressing. Okay, all right. So basically, what happens sometimes that you can examine the network part of the destination address and then forward the packet to the corresponding destination. So let us see how the lookup operation in classful addressing looks like. So you have a incoming destination address. Okay. Now from here, what you do, you first identify what is the address class. Okay. So first identify the what is the address class. Then you can identify the net ID, what is there. With this network ID, you go to the corresponding forwarding tables of class A, class B, and class C, and assuming that you have the information of the corresponding uh, host addresses in your forwarding table. So with that, you know that okay, what should be the corresponding outgoing port, and then you forward the packet here. Now, if they do not belong to A, B, and C, that means D and E is not used anyways. So if it is D, then it simply goes via this. You need not extract the net ID separately and then go with that. And then try to find out the corresponding outgoing port. You need not do that in that case, okay? Because D will deal with multicasting, okay? So this is how the classful addressing basically looks like. All right. So this is pretty straightforward, as you can see here. Now, what do we use in general? We generally use CIDR, okay? Classless addressing, okay? So, what is the most generally used prefix matching technique or most generally used lookup algorithm? Okay, so firstly, we use longest prefix matching. Okay, we all have studied, even in our networks course, we have studied that what is the way in which we try to find out that what is the corresponding outgoing port for a particular IP address in the forwarding table. Okay, so the easiest algorithm that we use is longest prefix matching. So you try to find out that which of the entries in the forwarding table matches most with the IP address that you are having currently at hand, and then the corresponding outgoing port is considered to be the port through which your address must be forwarded to, or your packet must be forwarded to. Okay, so that is your longest prefix matching. Now we have already studied in our networks course that longest prefix matching is not that efficient, because you have to go through, you have to read the entire 32-bit address for every incoming packet. Okay, so this is the problem that we have when it comes to longest prefix matching, and therefore we try to look at some better ways to or efficiently find out what should be the corresponding outgoing interface. Okay, so I think this is an example that is there for longest prefix matching, and you can see that the forwarding table is already having information about what is the destination address range and then what is the corresponding link interface. So whenever your packet comes stamped with the destination address, you check the entire IP address, and then you try to find out that which of these matches most with your IP address, and then you go to the corresponding outgoing interface. Okay. All right. So why are the difficulties that are there for longest prefix matching? So first is that a destination address does not explicitly carry the net mask information when a packet traverses through. That is true. Okay, it does not explicitly carry the net mask information. It just carries the total IP address with it. Okay. Then what do we have? The prefixes in the forwarding table against which the destination address needs to be matched can be of arbitrary length due to network aggregations. This is also true in when we are looking at network prefixes. Um, it is very difficult to match, okay, if you have network aggregations with it. Now, of course, if you are searching for long prefixes, you need to determine the length of the longest matching prefix, and you need to find the forwarding table entry containing the prefix of this particular IP address that you are looking at. Okay. So what do we need for better longest prefix matching? We need very high lookup speed. Okay. Now, how do we get to high lookup speed? Okay, so lookup speed is in general measured in terms of the number of memory accesses. Okay, so what is the bottleneck that we have? The bottleneck is the cost for memory access. Okay, so what do we need to do? We need to find out ways so that we have minimum memory usage. We have scalability both in terms of speed and memory. That means we need to have fast lookup and take less memory accesses. Then the updatability of routes should be much more efficient. Okay, that means your algorithms should support incremental updates because of the route changes that are happening. Okay, as I told you earlier also, that in a routing algorithm the efficacy is also dependent upon that how good or how nicely or how perfectly it is taking care of all the updates that are happening in the paths. Okay, so the updatability of the routes is also very important. Now there are various algorithms in the literature that have been proposed in order to enhance this lookup speed. Okay, so today in this module we are going to look at some of the algorithms which help in enhancing this lookup speed. Okay, so first is naive algorithm. Okay, it is called a naive algorithm because it is a very naive algorithm. So this is known as the simplest algorithm for finding the best matching prefix. Okay, so first is that first methodology that is used in naive algorithms is that it simply uses linear search of prefixes. How does it do that? It uses an array in which prefixes are stored. They can be stored in any fashion. Okay, so the storage is done in an unordered fashion. So, but what does this algorithm do? It just iterates through each prefix and compares it with the destination address. It is a simple search algorithm. Okay, so simply searches all of the prefixes and tries to see that whether it matches with the prefix, with the destination address that the packet is having. If something matches, then great, it is a best match. Otherwise, the search will continue. So this naive algorithm is nothing but a simple search algorithm. All right. So of course, the complexity will be O of n. Okay. Now, if n will increase, then your search time will degrade. All right, and also because you are keeping all of this information in your cache, okay, root cache, so that is also going to be a problem every time when n is becoming large. Then you will not have sufficient storage for storing all of that information, no. So that is one issue. Now, one of the enhancements that can be used for these cases is use, locality of reference, and then um, you know keep those packets, keep those addresses which are very which have a high hit ratio, but still it is still going to create a lot of execution, I mean inefficiency in execution time and all that. Okay, so I think this one is pretty clear to all of you that what are the issues when it comes to naive algorithms. Let us come to a better one that is better than naive algorithm, better algorithm, and it is known as binary trie. Okay, so trie is kind of a tree only. Okay, its literal meaning is that tree like. Okay, so tries are class of algorithms that behave like a tree. Okay, so now this is what we are going to use in order to look up or classify the IP addresses. Okay, or not IP addresses, the prefixes, sorry. So now what do? We need to use bits of prefixes to branch the tries. Okay, and then we can have like properties like trees, like it can have either 0, 1 or 2 descendants. The left branch of a node is labeled as 0 and the right branch is labeled as 1. Okay, and a node L represents a prefix formed by concatenating the labels of all the branches in the path from the root node to L. Let me show you how it works rather than this theory. Let us look at this part. Okay, so P1 represents the prefixes that start with 0. Okay, so 0 star. P2 represents the prefixes that have this much, that is 4 zeros followed by a 1 and then a star. P3 represents 001 star and so on and so forth. So these are the prefixes that you have. Now you need to represent it using a binary trie. How are you going to represent it? As it is already told in the tries definition, the left branch is denoted with 0, right branch is denoted with 1. Okay, so 0 will represent 1 bit of the prefix. So 0 star, if you're looking at 0 star, so you have to go from the root node to 0. Star means all the other prefixes that can start with 0, they are a subset of this P1, right? So P1 is here. Now let's go to P2. P2 is 4 zeros followed by a 1. So that means 0, 0, 0, 0 followed by a 1. So that will be the right child of this node. So there comes P2. Similarly, P3. P3 will be 0, 0, 1. So that is P3. Now again you have P4, that is 1 star. So that comes out here. You have P5, which is 1000. So 1000. You have P5 here. P6 is 1001. So 1001. P6. P7 is 1010. So 1010. P7. Similarly, P8 is 1011 star and P9 is 111 star. You can find this out here. Okay, so basically this trie is representing that how you are keeping the prefixes inside your system. Okay, so now when there is a lookup, okay, when you have an address and you want to find out that what is the best prefix match for your particular address, you can simply traverse through this and you can find out that what is the best matching prefix for you, and and then once you get your best matching prefix, you can then get the corresponding outgoing interface from the table, and then you can forward the packet. Okay, now why it is being done? Rather than traversing over n times, you can traverse the trie. What will be the complexity that will be there for this kind of a trie structure? Any ideas for this? I'm sure all of you have done your data structure courses. Now what will be the complexity?
Ma'am, is it login?
Should be login, right?
Yes, ma'am.
When it comes to the longest path. Okay. All right. So now what are the advantages that you will get? Okay, in these kind of scenarios, when you have a binary trie, your insertion and deletion also becomes easier. Okay, so if you want to insert a prefix, then also it is easy. You can just traverse to the corresponding nearest node and then you can add the prefix there. That is also very easy. Like here, I think P10 has been added and P11 has been added. P10 is 110 star and P11 is 0110 star. Okay, so it becomes very easy for insertion of new prefixes if you want to. So that's when your updation also becomes very easy in those cases. Now this is how you can implement your binary trie with the help of pointers. Okay, so P1 and P4 are representing 0 star and 1 star, and from there you can have left and right child, and correspondingly you can have pointers that will help you to go to the or help you to find the corresponding prefixes. Okay, so this is how the implementation of binary trie happens. All right. Okay. So this is the worst case complexity that I'm talking about. Okay, so worst case search complexity is O of W. Okay, where W is the number of nodes. Okay, this is the worst case I'm talking about. So worst case is O of W, and update that insertion complexity in worst case again is OW, and deletion again worst case complexity is O of W, and memory consumption is O of NW when N is the prefixes, number of prefixes. Okay, you can have better complexity when it comes to best case and even your moderate cases. Okay, so this is what your binary trie basically helps you out with. Okay, these are the advantages that you have with binary tries. All right. Next, we will get to path compressed tries, but I think we have only 1 minute left for the class. So I will stop the class here. Now, not even 1 minute. Okay. So the class is, the time is over. So I will not go ahead further. So let me stop the class here today. And if you have any question, you can ask me. Otherwise, what I will do is I will try to send you all the